Time for decision theory. Decision theory. So what is decision theory? Well, it all stems from a very simple idea that we want to minimize expected loss. What does that mean? Well, we'll see an example in this video, and then we'll explore this in a little more detail. So my goal for this little section of videos on decision theory is to show how this idea arises naturally by thinking about what we're really trying to accomplish in particular in classification and supervised learning and regression. And then by exploring this idea, we'll see how a lot of the core concepts and the main ideas in machine learning fit into this broad sort of big picture that arises from thinking from a decision theoretic perspective. So let's start with a little example. So think about spam. When you get spam in your email, in your inbox, that's, it's like an advertisement or something that you weren't interested in. And think about if you were trying to build a classifier, some program to recognize if whether a particular email was spam or not. So you get some input X, and X may be the text of the email, for example, and you want to predict whether it's spam or not spam. So Y would be, say, 1 if it's not spam and 0 if it's spam. So Y would be a class. And we want to predict Y with our prediction Y hat. So this matrix that I'm drawing over here, we're going to have, let's see, we'll say spam. So this will be the true. This will be, let's see, this will be the true Y's. Actually, let me make a little room there. So this is spam, and that's Y equals 0, we said. And we'll call it, if it's good email, we'll call it ham. So that's Y equals 1. And it's the true because it's Y. And here we'll put spam and ham. And this is what we classify it as. So this is Y hat for our prediction. Y hat equals 1. So this part is prediction, and this part is true. So this is what's true. And let's think about, so what are we going to put in this matrix? Well, let's think about this box. If it's spam, right? If the true it's actually a spam email, which we don't want, but we classified it as ham, and then maybe our program sends it to our inbox, and that's bad. So let's say we get a loss of 1. So we're going to put our loss in, the loss that would occur from this prediction under this state in this matrix. So let's, in some arbitrary units of loss. Maybe this is something like the time that you waste by making this wrong classification. And now let's think about this one. Let's say that it's a good email. It's maybe an email that you were wanting, and then the classifier, your classifier classifies it as spam, so that's very bad. Maybe that's a loss of 100. If it's an email from your boss or something that you really needed and you missed it, maybe when you classified it as spam, it went into the spam box and you didn't see it. So that would be very bad. And if it's good, or if you correctly classify spam as spam, let's say you get a loss of 0, and if you correctly classify good emails as good emails, you get a loss of 0. So this is what we call a loss matrix. Loss matrix. And we can define a function, switch colors. We can define a function L, a loss function, associated with that loss matrix. And it takes 2 arguments, Y and Y hat. And it's just a function that defined by this matrix. So now let me describe a little more. This was a particular example, a little more general framework that the sort of more general framework in decision theory is that you have some state. So this is framework, general framework, general setup. You have some state, sometimes they call it the state of nature, and let me denote that by a little s. And this is unknown to you. So in our example, that would be like whether it was actually a spam or a ham email. And then you get some observations. Observations? Maybe I'll call that, well, let's not call that anything for now. But that would be, for example, in our example, that would be like X. You get to see the email. And then you have to make some decision, or you have to take some action, and let's call that little a. In this case, it would be predicting spam or ham, and then you incur some loss. L, let's say L of S and A, it's a function of the state and the action. So you're using the observation that you get to try to figure something out about the state. So this is known, of course. You observe it. And this is known, of course, because you choose it. And this is sort of the general framework. You can think about it as sort of a game where there's some state, you get observation, you take an action, and you get a loss. And let me point out here, so like I said, I'm describing them as losses, which is sort of the standard statistical perspective, maybe a little bit pessimistic. You could also think about as, instead of losses, you could think about rewards or utility. And you just take this would be like if you had a negative loss, we could have had negative numbers in here. Negative loss would be like a reward or utility. So a loss is just like, if we took the negative of this, then we could think about that as a reward matrix instead. So I didn't really say these. I used non-negative numbers here, but more generally, this loss, this is just some real values. This was one little example of a loss matrix, and let me give you another couple commonly occurring examples that turn out to be important in particular for machine learning. So the first one is what's called the 0-1 loss. And this is the loss of y and y hat equal to the indicator function that y is not equal to y hat. So here, if you predict the wrong value, if you predict the wrong y hat, then you incur a loss of 1. And if you get it right, you get loss of 0. So right, this is just 0 if y equals y hat and 1 otherwise. And this is usually used in classification. So for binary classification, for example, this would look like we'd have our little loss matrix, something like this, where, let's see, it would be if they're the same, it's 0, 1s, and 1s. And you can contrast that with this case. So what's important about this, so what's different about this type of loss than this one, is that here, you're going to, if you want to minimize your loss, you're going to design a very different sort of classifier than in this case, because here, it's super bad if you classify a ham email as spam. So you're really going to be you're going to be very reluctant to classify emails as spam, whereas in this case it's just the same. So you're going to be a little more balanced in this case. So this, by thinking in terms of this loss matrix or this loss function, it will definitely impact how you design your classifier. Here's another example, commonly occurring loss function is the square loss. And square loss is used typically in regression. It's often used for regression, very important loss function. And it's just the square of the difference. So those are a couple little examples of loss functions, and this was just a very simple example to illustrate why taking the loss function into account is an important thing to do when you're thinking about what you really are trying to accomplish with the system that you're building, the classifier that you're building.